There are two states of energy, kinetic and potential. Kinetic energy is the energy of motion. Potential energy is stored energy. Energy comes in 6 forms that represent the different ways energy can be stored in a system. The 6 forms of energy are radiant, thermal, electrical, mechanical, nuclear, and chemical. Radiant energy is kinetic energy. It's the energy of electromagnetic radiation that travels in transverse waves. Radiant energy includes visible light, X-rays, gamma rays, and radio waves. Thermal energy is kinetic energy. It is more commonly known as heat. Thermal energy is the total energy of the moving atoms and molecules in a substance. As a substance heats up, the atoms and molecules within it move faster. Electrical energy is kinetic energy. It's the movement of charged particles called electrons. Mechanical energy can either be kinetic energy or potential energy. When an object is in motion, like a train moving down the track, it has kinetic energy. When that same object is at rest on the top of a hill, it has potential energy. Nuclear energy can be kinetic energy or potential energy. An atom can split through a process called fission or fuse with another atom through a process called fusion. These processes release large amounts of energy. This is an example of how kinetic energy, because particles and energy are moving, the energy holding the atom together is considered potential energy because it is stored energy. Chemical energy is potential energy. It's the energy stored in the bonds of an atom, a molecule, or a compound. Today we're also going to talk about energy transformations. Energy transformations. Energy transformation is the process of changing one form of energy into another within a system. Energy cannot be created nor destroyed under normal circumstances, but can always be transformed in a system. Scientists call this the law of conservation of energy. Energy flow diagrams are one way to visualize how energy transformations can occur within a system. These diagrams show, in a sequential format, the energy source and the energy output. For example, a toaster's energy source would be electrical energy, and the energy output would be thermal energy. In some cases, the transformation can generate multiple energy outputs. When electrical energy is used to power a light bulb, both radiant energy and thermal energy are produced, so both light and heat. So here's an energy source, electrical energy, and its energy output is thermal energy and radiant energy of a toaster. Energy transfer. Energy can move between systems through a process called energy transfer. The 3 basic ways energy can transfer between systems are conduction, convection, and radiation. We know these. Conduction occurs when energy transfers from one system to another by direct contact. An example of conduction is cooking pancakes on a griddle. The pancake batter is in direct contact with the hot griddle. Convection occurs when energy transfers between 2 systems through the movement of fluids like air and water. An example of convection would be using a hairdryer to dry your hair. The hairdryer is an excellent example of convection because the hairdryer heats up and pushes air, a fluid, towards your hair. Radiation occurs when energy transfers between 2 systems through electromagnetic waves. Radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays are all examples of electromagnetic waves. It is important to note that radiation does not require travel through any type of matter. This means that the transfer of the energy through radiation can occur in space. The sun transferring energy to the Earth through space is one example of radiation.